Welcome. This is Algebra 1, Lesson 2.7. We're going to deal with solving equations with variables on both sides. So solving equations with variables on both sides. All right, so in solving equations with variables on both sides, you need an intermediate goal. So number one, intermediate goal. Intermediate goal. This is what you're working towards. This is very important because solving equations means to isolate the variable, right? Get the variable all by itself on one side of the equal sign. Okay, well, to do that, you have to choose a side. And so really the intermediate goal for solving equations with variables on both sides is to choose a side. Choose a side and move all variables to that side. Choose a side and move all variables to that side. So, first off, let's deal with the aspect of how you move them. So, how are they moved? How are they moved? That's the question. All right, let's take a look at an example equation. Let's suppose we had something like this. Now, this will not involve moving the variable. 3x minus 7 equals 9. 3x minus 7 equals 9. All right? And then I want to look at an equation like this. 3x minus 7 equals x plus 9. All right, so what we're dealing with today is the aspect of variables on both sides. As you can see, you have a variable on the left and you have a variable on the right. Okay? So how do you move the variable? So we have a choice. Do I want to move the variable, the x that's on the right, to the left? Or do I want to move the 3x that's on the left to the right? It really doesn't matter. It's your choice. I always like to move the variables that will end up with the variable being positive, and I'll mention that a little bit later. But that's what we have to do. Now, if you look over here, the first equation, it's just a normal everyday equation, right? What's the goal? Again, isolate the variable. There's the variable, the x. We got to get it all by itself, and we got to move. We got to move two things. We have to move the 3 that's multiplied times the variable, and we have to move the negative 7 that's added to the variable. How would we move the negative 7? We would add its opposite to both sides, right? That would allow us to move the negative 7, and we would end up with 3x equals 16, and we would finish off that equation. Okay. In our situation right now, we want to move this x from the right to the left. So how do we move it? How do we move it? Well, first off, let's understand in reality it's a 1x, right? We don't show those 1s, but an x is a 1x. They're moved exactly like you would move any quantity added to the variable. We simply add their opposite to both sides. I'm going to add a negative x to both sides of the equal sign. I'm adding a negative x to the left side of the equal sign and a negative x to the right side of the equal sign. That is going to allow these to add out. So how are quantities moved? Answer: by adding their opposite to both sides. By adding their opposite to both sides. And we already know how to do this, don't we? Of course we do, right? So by adding their opposite to both sides. Okay. That's the aspect. How are they moved? Add their opposite to both sides. Little b. Which side should be chosen? Which side should be chosen? The answer is it really does not matter. Okay? It doesn't matter. Okay? You can do it either way. It's your choice, but I'll say this. It's safest. It's safest, meaning the less probability of a mistake, moving the variables to the side that will cause the sum to be positive. It's safest to move the variables to the side. It's safest to move the variables to the side that will cause the sum to be positive. That will cause the sum to be positive. Okay, this is not a hard, fast rule. This is simply an aspect of something that is wise to do. Okay, it's safest. But honestly, you can choose to. Some students always move the variables from the right to the left all the time. Always, always, always. That's fine. Not a problem. Just be careful at times when your variable's negative, but it's not a problem. Okay, but it's safest to move the variables to the side that will cause them to be positive. But that's your choice. Okay, let's get into some examples. See examples. Examples. Number 1. All right, something simplistic. Let's go 7n minus 3 equals 4n plus 2. 7n minus 3 equals 4n plus 2. Notice we have variables on both sides of the equal sign, right? 7n on the left, 4n on the right. And so we have to choose either to move the 7n's from the left to the right, or we have to choose to move the 4n's from the right to the left. Okay, so because we're going to be adding their opposite to both sides, moving the 7n would require adding a negative 7n to both sides. That's going to cause me to have a negative variable. Moving the 4n will cause me to add its opposite to both sides, at which case then I'll add a negative 4n to both sides. So my choice is going to be move the 4n to the left. Move the 4n to the left. So again, use your color here, and it'll be obvious when you go back and look what we did. So like we move quantities added, I'm just going to come underneath and use the vertical approach instead of the horizontal approach. And I'm going to add negative 4n under that 4n, right? I want to move it to the other side. It's going to add up to 0, and that's how it moves. But for this to be proper, whatever you do to one side, you have to do the same thing to the other. Okay? Again, some of you like to draw horizontal lines. That's fine if you want to put that there. Now let's add up our like terms on the left. Right, so I'm looking here at 7n minus 4n, right here. So 7n minus 4n is 3n. I still have to bring down the negative 3. That equals, again, my 4n minus 4n, that's 0, right? That's how that moves. And so that is 0. Thank you, Smartboard. And so that leaves the positive 2. Okay, now we're at the point where we have a regular equation just like before, and we're going to solve this thing just like we solve any other equations. All right, let's move the negative 3. We'll move it to the other side as we're trying to get the n all by itself. Right now we're at 3n equals 5. Now we need to move the 3. And again, we can multiply both sides by the reciprocal, or take the shortcut and divide by 3. And we end up with n equals 5/3. Right? And that's the solution, and we're rolling on to the next problem. And that's what these are like. Solving equations with variables on both sides. Okay? Solving equations with variables on both sides. Let's do another example, number 2. How about something like this? 10 minus 7x equals 6 minus 3x. 10 minus 7x equals 6 minus 3x. So again, notice we have variables on both sides. I have a negative 7x on the left, and I have a negative 3x on the right. To move the negative 7x to the other side, I'll have to add a positive 7x to both sides. That would give me positive x's on the right. If instead I move the negative 3x from the right to the left, I'll have to add a positive 3x to both sides, and that will leave me with a negative quantity. So my choice is going to be to move the negative 7x. Move the negative 7x. Okay, again, how do I do it? By adding its opposite to both sides. So I'm going to add a positive 7x to the left side of the equal sign, a positive 7x to the right side of the equal sign. Okay, on the left side of the equal sign, the only thing left is the 10. On the right side, we still have the 6. 3 negatives and 7 positives leaves us 4 positives of them, of what's, of the x's, right? And so we have positive 4x. All right, finish off the problem. What do you do when you have things both multiplied times the variable and also added to the variable? As you remember, you move things added first. So we're going to add a -6 to both sides to move that 6. And we end up with 4 equals 4x. And we're going to move the 4 by multiplying both sides by the reciprocal, or we can do the shortcut and just divide by 4. And we're going to end up with 1 equals x. 1 equals x. And on we go to the next problem. Right? 1 equals x. C. How about something like this? I'm sorry, 3. How about something like this? How about 4x plus 2x minus 9 equals x? All right, a problem like this puzzles students sometimes. It shouldn't. We have the same situation. We have x's on the left, a couple different ones of them, and we have x's or variable on the right. So again, my choice is the same. Do I want to move the 4x and the positive 2x to the right, or do I want to move just the x to the left? Well, it's my choice, but I'm going to move just the x to the left. So move x to left. How do you do that? Add its opposite to both sides. So I want to add a -x to the right, and whatever I do to one side, I'll have to do the same to the other side of the equal sign. Okay, so look at where we're at right now. Right now here on the left, I'm ready to add up like terms. 4 of them and 2 of them is 6 of them. 6 of them minus 1 of them is 5 of them. And I hope you agree that that's 5x. Still have our -9, right? We have our equal sign. And for some reason, students get all goofed up here. But x minus x is 0, and that's just a 0. Don't let that cause you any consternation. It's just a 0. Okay, we're ready to finish off, right? We're ready now to isolate our variable, get it all by itself on the left-hand side of the equal sign. We're going to have to move the 5 and the -9. We always look to move things added first by adding their opposite to both sides. So I'm going to add a 9 to both sides. We get 5x equals 9. And again, things multiply times the variable. You move by multiplying by the reciprocal. Again, I keep showing you both ways so you get used to both. Shortcut as well, right? And we get x equals 9/5. Okay, and on we go to the next problem. All right. Okay, so all this is underneath big number 1, and that was intermediate goal. So this is going to be number 2. Number 2. At times, simplify and combine like terms before moving them to one side. Simplify and combine like terms. Simplify and combine like terms before moving the variables to one side. Before moving the variables to one side. At times, simplify and combine like terms before moving the variables to one side. You might say, well, okay, how do I know when to do this? And it's hard to give you a specific written answer. I mean, I can, but it would be so long, it's just not worth it. So the idea is this. Basically, when you have distributing to do, you want to do your distributing, and then you're going to take a look at it and determine whether or not you want to combine like terms before moving. So you have to look at each situation is a little different. But whenever there's distributing involving the variable, you want to do that distributing. So let me show you an example. A here, 3 times the quantity, 2y minus 7, equals 4 times the quantity, 3 minus y. Now in this situation, there's no way we can move anything yet. We have 2 distributings to do, and we've got to take care of it first. 3 times 2y is 6y, and the 3 times the -7 is a -21. Let's now distribute the 4 on the other side. 4 times 3 is 12, and 4 times a -y is a -4y. Now I'm ready to do my moving, and I hope you would decide I'm going to add a positive 4y to both sides. Again, you could do it the other way. You can move the 6y I know that this is going to give me a positive variable. So we have on the left 10y's, right? Minus 21 equals 12. Let's finish it off. Let's move the negative 21 by adding its opposite. We're left with 10y on the left and 33 on the right. Multiply both sides by the reciprocal, or do the shortcut of dividing, and we end up with y equals 33/10. I'm looking if that can be reduced. It can't. 33, 3 times 11, 10, 2 times 5, so no reducing. And so that's it. I'm done, and I'm ready to roll on to the next problem. Okay, let's try one more here. This nature, B. So what would you do with something like this? 2 times the quantity, x minus 3, plus then of 6 equals 3x plus 2 minus the quantity, 2 minus x. Okay. So again, there's no way to choose a side yet because the variables are involved with the distribution. So there's distributing to be done. We've got to do that first. So let's start on the left. Let's distribute our 2. 2 times x is 2x. 2 times negative 3 is negative 6. All right, continue with what's left on this side. We still have a plus 6 equal 3x plus 2. And remember now we're distributing this negative sign, and it's just like distributing a negative 1, right? So negative 1 times 2 is a negative 2, and negative 1 times a negative 1x is a positive 1x or positive x. Okay, that's where I'm at right now. So at this point, I can choose to either add like terms or I can choose to start moving the variables. Because I want to move the positive 2x from the left to the right, I don't need to add up these like terms right now. You can. Fine. If that helps you out and that's better in your mind, then do that. But it's not necessary at this point. So I'm going to move the positive 2x by adding a negative 2x to both sides of the equal sign. Again, remember, I'm doing it to the left side of the equal sign. I'm doing it to the right side of the equal sign, right? That's the idea. You're maintaining your sides. Okay. What do we end up with on the left? Well, that's 0, but that's also 0. So we've got 0 on the left. That's fine. Not a problem. What do we end up with on the right? Okay, so 3x minus 2x is 1x. 1x and 1x is 2x. And again, we have 0. So in this problem, we have 0 equals 2x. Hopefully you already know that the answer is going to be 0 because 0 divided by anything is 0, and we end up with x equals 0. And so we end up with x equals 0, and that is the solution to this equation. All right. A couple other situations here. Number 3. Number 3. What does it mean if the, what does it mean if the, and I'm going to go to red. What does it mean if the, and then in red, variables add out? What does it mean if the variables add out? Okay. Well, there's a couple of different situations, okay? We'll come back and answer that question in a minute. Let me show you what I mean. A, 3n minus 5 equals 4 plus 3n. Okay, simplistic equation. We want to move our variables to one side. Okay. Well, whenever you have the same thing on both sides of the equal sign and they're the same sign, they add out. And usually you just cross them off. Why are you able to do that? Because if I take the 3n on the right and try to move them to the left, I'm going to add a negative 3n to the right, and I'm going to add a negative 3n to the left. So notice this is 0, and this is 0. They add out. So again, hence you could just quickly cross them off. All right, what do we end up with? Negative 5 equals 4. You want to now assess this solution. This is not true. And because this is not true, that implies there is no solution. Because the result was not true. -5 does not equal 4. So what does it mean if the variables add out? Well, if when the variables add out, the result is false, there's no solution. Let's do one more example. What about something like this? 7x minus 3 equals -4 plus 3x plus 4x plus 1. Okay. So if on this one I add a -7x to both sides, this is 0, and this is 0, right? It's a -7x. Okay, what's left? -3 on the left, and let me add up what's on the right. Oh, that's a -3 as well. Right. What is left now is true. If what is left is true, then the solution implies all the real numbers. Right? And so we can give the symbol, which again is all the real numbers. All the real numbers. Okay, that's the lesson for today. Hope you'll do well with it tomorrow in class.